Good morning, grade 8. How are you? I hope you're safe. And please, yes, stay safe, stay away, stay at home, and do a little bit of your work. So, today we're going to be looking at ecosystems. So, today we'll be looking at ecosystems. And you can use your textbooks, your mind action series. You can refer to them and you can make use of them after this presentation. I want you guys to answer the questions that I sent you on the worksheet through the WhatsApp group. Let us start by the definition of ecosystems. What is an ecosystem? An ecosystem is the interaction between the biotic factors and the abiotic factors. Interaction between biotic and abiotic factors. So in an ecosystem, we find two main factors that come together and they interact with each other. And what are those two factors? Biotic plus abiotic factors. So this is our ecosystem. All right. We did look at some of the biomes in term 1, so we'll not be repeating that. That makes up part of an ecosystem as well. However, our biotic factors are comprised of the main groups, two main groups, which are animals or plants. So animals and plants interact with each other either as they depend on each other for food or for shelter, and we've got different relationships that exist in an ecosystem. We've got the food chains that will be coming up, which will be the next topic which follows after this. So we always start with the plants because they are autotrophic, meaning that the plants, you remember that our first topic was photosynthesis, because plants make their own food. So animals depend on plants for food, and as a result, in the food chain, we always start with the plants, followed by animals, and animals are heterotrophs. All right? So that's hetero. Trophs, meaning that they cannot make their own food. This group of organisms depend on the autotrophs. The autotrophs, they make their own food. Auto is self, so the troph is the feeding level, so they feed themselves. And the heterotroph depend on that. So there is interaction which happens between the plants and the animals, in the sense that the animals depend on plants for food. But they do not only depend on each other for food, but they depend on each other for other things as well. And those things are not living, and hence they fall under the group abiotic factors. All right? So the abiotic factors are the ones that we need to expand more in this lesson. So the abiotic factors are the non-living factors. These are non-living, all right? And however, they are very vital to sustain the life of the animals and the plants. So the abiotic factors are important because they sustain the biotic factors. So we can say that the biotic factors the living organism depend on the non-living organisms for survival in a confined environment, and that confined environment is called an ecosystem, which can be a pond, which can be a forest, which can be a grassland, which can be a desert, any of those ecosystems. And these ecosystems can be natural, meaning that the ones that are not interfered by man, like the savanna, the grassland, the rainforest, etc., etc. Or they can also be man-made, like a pond. You can have a pond at the back of your house. You can even have a water tank as well in the house where you put your goldfish and all these other tiny fish inside. That is an ecosystem. However, that type of an ecosystem is an artificial ecosystem, because if you look at the water tank that is in the house, you have to feed the fish. But if you look at a natural ecosystem like a dam or a lake, you don't have to go and feed the fish once they are hungry. They rely on each other. So the animals also depend amongst themselves, as well as they depend on plants for food. So back to the non-living factors, the abiotic factors. So it's very important that the biotic factors get the non-living factors to sustain their lives. All right, what are some of these abiotic factors that living organisms need to sustain life? We've got the soil factors. So, soil is a very important component of the ecosystem, because everything is on the soil. We build our houses on top of the ground. The plants need to have soil in order to anchor their roots so that they'll be able to absorb the different minerals from the soil, etc., etc. So the soil is a very important factor which which is there to support the living organisms, as well as optimum temperature. Every organism must be able to survive within a uniform and optimum and best temperature, suitable temperature. So temperature, all right, like the camels, they are used to the desert, and which means that they are adapted to survive in very hot conditions. But if you look at the polar bears, for instance, in the Arctic, they are used to snowing and very cold, extreme cold conditions. So those organisms need to be left in their natural habitat. So we cannot take a camel and place it in an attic, or take a polar bear and place it in a desert. Otherwise, they will not be able to survive. So organisms are adapted to survive specific range of temperature. Then the next one is light. Light is very important for both the plants and the animals. For photosynthesis, you still remember the word equation or the chemical equation for photosynthesis, that we include sunlight. So plants cannot make their own food without sunlight. So plants need sunlight. And also, when it comes to animals, in as much as animals can be divided into two groups according to their demand of sunlight, of light, they do need light in order for them to be able to hunt. That's the predators. should be able to identify their prey as they move around using that natural light, as well as the prey must be able to identify the predators so that they will be able to run away for their own safety. And somehow the animals balance themselves. Yeah, they do get eaten despite the presence of the light, but light is a very important factor, and also they need to see their surrounding. Then based on the light, as I said, the behavior of organisms is divided into two groups. So organisms are divided into two groups according to their behavior for light dependence. We've got diurnal organisms like us. These are organisms that are active during the day, and nocturnal. These are organisms that are active during the night. All right. And the next point is the physiographic factors. The physiographic factors refers to the altitude, which is the level of the land above sea level. The altitude of the land above the sea level. Then we also have rainfall, as well as climate. Whether the rainforest is a very wet ecosystem or biome, in the sense that it gets a lot of rainfall, and it also has moderate temperature, not too cold, not too hot, in between, because it's very humid. And as a result, this humidity contributes also to the adaptation of those organisms. Then you look at the desert, it's a very dry ecosystem which has got very little or no rainfall, and it's very hot. So the temperatures are regulated by the land and the sea breezes during the night and during the day. So these organisms are adapted to survive under those specific conditions. Then the other abiotic factor are the gases. All right, very important to note that there are three very important gases that organisms need. And as much as the atmosphere is a mixture of gases, there are different types of gases that are in the atmosphere. But of these gases, we just mentioned oxygen, which is a raw material for respiration. You remember we looked at respiration. There's carbon dioxide, which is also a raw material for photosynthesis. And lastly, we've got nitrogen. And nitrogen is needed in order for formation of amino acids. And amino acids are used for protein formation. So nitrogen is needed for growth in all the living organisms. So but the biotic factors need nitrogen in order to make smaller units which are needed during growth, and these smaller units are called amino acids. And when amino acids are joined together, they form proteins, and proteins are used for growth, as I said, and also to repair some worn out tissue or to replace some old tissues during the process of growth. And so these are the main abiotic factors that occur naturally. And we also have forest fires, which is an extra abiotic factor. This one I call it an extra because forest fires do not occur in all for the ecosystems. Forest fires are very important in the growth of specific type of plants. If you look like during summer on the news, you observe this news video of the Eastern Cape and the Western Cape, and there will be these forest fires, and the forest will just be burning. Those fires are very important because they allow the rejuvenation of the soil, number one. Number two, they also allow the seeds of the plants that we find in those ecosystems, which are called the fynbos or the fynbos, to be ready to germinate for the next season. So fires make a very important part of specific ecosystems, but not all the ecosystems. And also after a forest fire, those ashes are very important. Those ashes will contribute as a natural manure, as it enriches the soil and it makes the nutrients to be recycled back into the soil. I'm going to clear up the board so that we proceed to the next point. All right, the last abiotic factor, I hope you took note of those that I've just erased. The last factor is the soil pH. And this is contributed. The pH of the soil is determined by the minerals that we find in the soil. So plants require minerals, just like human balanced diet has mineral salts. Plants also need the minerals. These minerals are dissolved when it rains, and then the plants absorb those minerals in form of a solution state or ion state up with their roots, and then the different type of minerals boost the growth of the plants so that they'll be able to have a healthy lifestyle. All right, so those were our abiotic factors. Once again, we say the pH, the fire, the light, the water, the rainfall and climate, which falls under water, as well as gases, which we say the gases include oxygen, carbon dioxide, and nitrogen. And lastly, the soil is an important part of an ecosystem. Now we want to move on to soil. All right, our next abiotic factor is the soil, and there are three very important types of soil. We've got the sand soil, we've got the loam soil, and number three is the clay soil. So these are the three types of soils that we have. So we have sand soil, loam soil, and clay soil. Now I'm going to characterize each one of those soils individually, and so that you'll be able to answer that table which I've given you. So please pay attention. So I'll start with the first one, which is the sand soil. Okay, sand soil is made up of large particles. Sand soil is made up of very large particles, and because the particles of sand soil are large, it means that the spaces that are in between the soil, the sand soil, are also large. So, large particles and large air spaces in between. All right, and that is very important to take note, because we spoke of air, which are the gases, we spoke of water. So if the sand soil has got a lot of empty spaces in between them, it means that when we pour water into sand, that water is going to drain through very fast. So the moment you pour some water into sand soil, the water immediately runs through those large air spaces. All right? And on the other hand, the large inter-air spaces also mean that there is a larger amount of gases, which is said that are important for both plants and animals. So if it rains or when it rains, we're going to have a scenario. Remember, we did mention of the soil pH and the presence of the minerals in the soil. So we're going to have a scenario whereby rainwater is going to fall down, and this rainwater is going to fall onto the sand particles and quickly run through the soil immediately, and it will do that very fast, not leaving enough time for the plants to absorb the mineral salts. All right, so sand soil loses soil minerals very fast due to the downward movement of water. As the water is moving down, though this water also moves down with the mineral, with the dissolved minerals. However, the good part of the sand soil is that it is large air spaces. So a very big question is that, is this type of soil good for farming? The answer is no. Sand soil is not good for farming. Yes, it might be having a lot of air inside it, but the problem is that each time it rains, the plants are going to be dry immediately. So it has got very low water holding capacity. What is water holding capacity? It is the ability of the soil to keep water without losing it due to the downward movement of the water. So because of the large particles, sand soil loses water very fast. So its drainage is very fast. So it's fast drainage and it gets dry very fast, and that affects the plants. Alright? So it's not good for farming. It's good to be there, the beach where you can just walk over it. It's good for building, it's good for construction, but not for plants. All right, let us look at number 2, which is the loam. The loam soil is the combination of the sand particles and the clay particles, meaning that it has got both large particles of soil and small particles of clay that are mixed together. And because there's an intermediate of there's a combination of big and small, it means that the large particles of the sand are going to create large spaces in between, and then the clay will come and fill in those spaces. All right, and then the other thing about the loam soil, it has humus. All right, what is humus? Humus is decayed plant parts, which can be the leaves or the roots or the entire plant or animals. So when biotic factors decompose, they form humus. So my question is, if humus is made up of dead plants or dead animals, is humus a biotic factor or an abiotic factor? It is a biotic factor. Why? Yes, the humus is no longer living because it's made up of dead parts, decomposing, okay? Parts, but of what? Of organisms that were once alive. So that's why humus is part of the biotic factors, not abiotic factors. And it's very important to note that in all the tissues of living organisms, there are some nutrients. And when each organism dies, these nutrients are decomposed, they are acted upon by microorganisms, which can be bacteria, by fungi, by tiny organisms like earthworms, and broken down into tiny pieces, and the nutrients that is inside those tissues is released back into the soil, and that nourishes the soil. So humus is good for the plants. It's a natural way of recycling the nutrients. So during the life cycle of an organism, it will be taking up nutrients, it will be making use of food. So when it dies, when it decomposes, it brings back those nutrients into the soil, and the soil becomes rich again. So humus is very important. So loam has got particles of sand, which are very big, particles of clay, which are very small, and humus, which is stuck in between. So humus has got a combination of things that are inside it. So when it comes to particle size of loam soil, we say it's mixed. It's a mixture of those three that are brought together. And how is the air spaces of the loam soil? The air spaces of the loam soil is not as much as the sand. It's a little bit less than the sand, but it's still a good amount of air spaces for anything which is living within the soil to survive. And then what about the water holding capacity? The ability to retain water, the ability to drain water. Loam soil holds water very good. It holds water very well. So when it rains, the water slowly looks down, and the water does not go directly like as in sand soil. It moves like in zigzag, and that delays the movement of the water. So the water finds spaces on that space, then it moves, it goes to that space, it goes to the right, it goes down, it goes to the left, it delays there because it cannot find its way down. And that gives sufficient time for the plants to absorb the nutrients, the minerals that would have been dissolved in the soil. So loam soil is the best soil. It is the best soil for plants to survive. All right, and it stays wet for a long period of time. So it has got also good water holding capacity. So it was good drainage, good water drainage, good mineral content, good air content. Everything about loam soil is good for survival of plants. Then lastly, let us look at number 3, which is the clay soil. As I said, the clay soil is made up of very small particles. You can refer to your textbooks there on page 29. The clay particles are very tiny, and because they are tiny, it means that the air spaces in between the clay particles will also be very, very, very minute. They'll be very, very tiny as well. And because they are very tiny, what does it mean to air and water? It means that clay has no or little air. No or little air. Alright, and then what about when it rains? When it rains, because it has got very tiny air spaces, the clay soil will get waterlogged. It gives that appearance of as if it's flooded outside, like it has rained a lot, even if it's just a few millimeters of rain. It gives the appearance that it has rained a lot. Why? Because the water is not moving down very fast. Why does the water not move down very fast? Because there's no space for the water to go down, since the particles are tiny and very closely packed, leaving little or no space for the water to move down. How about water retaining? Clay soil retains water, a lot of water, which is not good for plants. Have you ever watered a potted plant? You water it, until it starts to rot. So too much water is not good for the plants as well. The plants will literally drown in the water, which is not good. They need time to develop their roots, look for the water and get a bit dry, then you water them. So too dry conditions like the sand is not good. Too wet conditions like the clay is not good as well. So it must be a balance, and the soil which balances is the loam soil. I hope you understood about the soil. Alright, then lastly we want to look at demands for plants according to the water demand for different plants. Different types of plants demand different amount of water. Alright, so we classify plants using the demand for water. Alright, and there are three groups of plants that we have according to demand for water. And I want you to pay attention very keenly. Alright, the first group. Okay, the groups are not in any order at all, but what you need to know is to link the characteristics of the plant to the specific type of environment or demand. Alright, so plants have got different demands for water, and it's very important why we're focusing water and plants, because remember we said that plants are autotrophs. They make their own food. So plants require water in order for them to survive. So plants cannot survive without water. So plants need water for survival. There has to be water for photosynthesis, and also plants do not have a skeletal system. They do not have bones like us. So the amount of water that a plant has makes the plant cells firm or turgid, and that turgid state, which is called turgidity, allows the plant to keep an upright position. The upright position is very important for plants' leaves to be exposed to the sunlight, and also to keep the flowers displayed for the pollinators to be able to identify the flowers so that pollination can take place. That allows the survival of the plant. So as I said, there are three groups of plants according to the demand of water. We're going to look at the first group. not in any order. You can start from whatever order, but pay attention to the characteristics. When you look at the characteristic, we will analyze the main organs of the plant, which are the roots, the stem, as well as the leaves. And on the leaves, we'll make special mention of the stoma, which are the openings of the leaves, or the cuticle, which is the layer which prevents water loss from plants. Alright, so we'll be making mention of those main properties on each and every one of those three groups. The first one is they are called hydrophytes. Alright, the first group of plants is called the hydrophytes. Alright, these are plants as the word hydro refers to water. Right? These are plants that we find in water. They survive in water environment. So you find them in the dam, in a water pond, around the rivers. Alright? And the examples of these hydrophytes are the water lilies. So water lilies are the examples of the hydrophytes, right? So a water lily is found in fresh water pond. Fresh water pond. We know that the water is divided into two categories: salty water and fresh water. So we find this in fresh water pond, and because they are already in water, they've got, there's no need for them to have well-developed roots, because the purpose of the roots have got two functions. Number one, to support the plant fixed into the soil. Number two, to absorb water. So the hydrophytes are already found floating on top of the water, like the water lilies. So there's no need for them to have well-developed roots, for the mere reason that they are not in dire need of water. The water is available and it's plenty of it. That's its habitat. Unless if the water pond dries up, unfortunately these plants will not be able to survive. They only survive in water. And also they have a very small, or what we also call reduced stem. The purpose of the stem is for transportation of that water and some storage food to the roots, which we say the roots are not there, so there's no need for the stem to be there. So it's very tiny, it's reduced, almost like as if it's not even there. However, they're very large leaves, the water lilies. So when you're characterizing them, think of the water lilies. What are some of the properties of the water lilies? It has got very large leaves, very fleshy, meaning that juicy. There's a lot of juice inside those leaves, and they have a lot of stomata. Alright, they do have a lot of stoma that are situated on the upper part of the leaves. Most of the plants have got stoma on the lower side. We say stomata for one and stoma for plural. Right, so those are a contradiction to the other groups, because their stoma are found on the upper part where there is sun shining, and the stoma are controlled, the opening and the closing of the stoma is controlled by light intensity. So why do they have a lot of openings where the sun shines the most? It means that they're going to lose a lot of water. Transpiration, which is the water loss from the plants, will take place. It's because it's already in a water biome. So a water lily survives in a water biome, so it does not need to save the water. It has plenty of that water, that's why it can afford to lose water. And there's no need to have the waxy cuticle which covers the water lily, because it does not need to limit transpiration. It can lose as much water as possible during the day and also absorb as much. So any water which is lost during the day is quickly replaced during the course of the day. So those are the characteristics of the hydrophytes. So hydrophytes are found in water. They have very small roots, a very short or reduced stem, or even absent in some of the plants, very large fleshy leaves, stoma on the upper part of the leaves. Those are the characteristics. Let us look at the second group of plants according to water demands. These are called the mesophytes. Mesophytes. Alright? The mesophytes are the plants that we find inland, the inland plant, alright? Except for those that we find in the desert. So all the other plants, all the other trees that you know, save for those that survive in a desert. Very easy. So the other trees, the other bigger trees, all right, this can be grasses, this can be the big trees, this can be your acacia trees, your all those big trees. These have they've got very long roots. Why? Because inland there's rain seasons, and during the different rain seasons, these plants need to be able to survive. They need to be able to survive such that they will be able to limit the amount of water which is they need to be able to keep up with the water demand by having long roots. So the roots are very long, they develop and they go down into the soil seeking for the different water tables. And some water tables are quite close, especially for those that are closer to water bodies like to the lake or to a dam. The water table is very close. So you expect the trees around a dam to be having shorter leaves than trees that are far away in a mountainous area. They have to have longer roots or deeper roots so that they'll be able to reach for that water. So these are the mesophytes. They've got very large stem, and the stem of these mesophytes is also covered with a bark. The purpose of a bark, the bark is that hard outer covering of the stem. As the plant grows old, that hard outer covering of the stem, this bark prevents transpiration. It prevents water loss. Since they are not in a water biome, so they need to minimize the water lost during the day. And then they also have reduced leaves. Most of them have smaller leaves, all right? And these leaves might have a waxy cuticle or might not have, depending, as I said, whether they're close to a water body or they're far away from a water body. And the stoma of these plants are on the underside, unlike the hydrophytes, which are on the upper side. They are on the underside because when a plant's leaf is like this and the sun is shining from the top, the stoma are already on a shaded area, so they will not be able to open that much. And reduced opening of the stoma means that there is less water which is being lost. Then the last group is the xerophytes. The xerophytes the ones that you find in a desert biome. A desert biome is one state, it's very dry. We analyze the biome, it has got little or no rainfall. So those plants have got very deep roots, they've got no stem, all right, or they have got what we call modified stem. It looks like leaves, but then it's a stem, and the stem is covered not with a bark like the mesophyte, but with a very hard or very thick cuticle. And then they have, some of them have no leaves. Those that do have stems will not have leaves. Those that do not have stems will have leaves. And these leaves are very fleshy to store water, and they are also covered by a very thick waxy cuticle, and they do not have stoma. They do not have stoma to avoid water loss since they are already in a very dry habitat. This is the end of the lesson. I hope you have understood and now you are able to do the activity that I've given you. Thank you so much and stay safe. Love you. Bye.